Hey guys, Pankaj here. Welcome back. So in today's machine learning, we are going to talk about decision tree. So we'll see what it is, where to use, what are the mathematical intuition behind it, and how to plot the decision tree after generating the model. Okay. So a lot of factors we are going to see. So let me share my desktop. Okay, so here is the agenda. So we'll see what is decision tree, where to use decision tree, and what are the various vocabulary involved in decision tree, because those kind of thing will be helpful when you guys are going for interview. Okay, so we'll see what is entropy, what is the mathematical formula behind this, and how we basically calculate. What is information gain, what is Gini impurity, what is pure and impure node, what is pruning, and some mathematical formula. Then we'll take one example and create a decision tree model. Okay, so before that, let me talk about what is decision tree. Okay, so let me just write here decision tree. Okay, so as the name said, right, based on the decision, the tree will be built. Okay, so what is this decision? Basically, it is, you can consider this as a normal if else structure. Okay, so let's say you have some condition. If this condition is true, do this, correct? Else, do this, correct? If you have multiple if else condition, if this condition, then do this if it is true. L if this condition is true, do this. Else, do this, whatever statement you have written. Okay, so based on that, you are basically forming a tree kind of structure, and that's what we are going to see here, decision tree, how it is basically made. So this is one of the simplest algorithm in machine learning, and because once you get the data set, based on the data, you can decide like how you can decide like where the data falls, and what kind of decision, when you make a decision, what kind of output you are going to get. Okay, so we'll take one example also, and based on that, I'll show you. Okay, so let's say you have some kind of example. Okay, so let's say I have some feature in the data, say A, B, and C, and here we have some target. Okay, based on some value, let's say all are nothing but categorical value. Categorical value or feature, I would say. Okay, let's say this feature is based on imply. Okay, so what is let's say age. So A stand for, let's say, all the age column, and B, let's say salary, and C, let's say department. Okay, so this age anyway, it will be continuous value, or it could be discrete also based on the format they have selected. Salary will also be kind of discrete or continuous based on the format selected. Department could be a pure categorical value. Okay, so here let's say based on that, they are targeting or their target values, let's say employee staying for, let's say, longer number of years in the company. Okay, or whether he is going to quit or not. Okay, so I'll just make, let's say, quit or no quit. Okay, only two categories are there, or basically two classes basically. Okay, quit and no quit. You can mention that this is 1 and no quit is 0. Okay, so based on their age, salary, department, what they are working, and if I put a data, and based on the data, let's say we label it as quit, and some based on some data we put as no quit. Okay, so while looking at the data, you can easily tell, okay, some person age is this and their salary is this, their department is this, maybe that guy is quitting. Okay, there is another employee whose age is this, salary is this, and department, maybe some other department, that guy is not quitting. Okay, so based on that, some categorical data is there. So we can put multiple if else condition here, and based on that, we can generate a simple model and predict whether that guy is that person is going to quit or not. Okay, based on their age, salary, and department. Okay, so that's what this if else will be helpful here. But what if you are going to build a decision tree model based on this decision tree algorithm? So what kind of thing will come into picture? Okay, so to talk about this, let me talk few terminology here. So to make a decision tree, right, let me just write here decision tree. We need two things. Okay, so for tree we need basically a root node. This is called root node. We'll see how to get the root node details, because there could be a number of possibilities, right? Then we have here, this is nothing but leaf. Okay, these two are leaf. Okay, so based on certain condition, here you put a condition here, and if it is yes, go this direction. If it is no, go to this direction. Okay, so this is called leaf. And here again, this is also known as decision node. You guys should very much aware of like what is leaf, what is root node, and what is decision node. This is also decision node. Okay, I'll mention decision node. Okay, again, if you're putting condition here, so again it will maybe yes, and this will become no. Okay, and there will be another data here, and let's say this is yes, and this is no, certain data. Okay, so this kind of thing is called all decision nodes. That is one thing. Okay, and here this particular thing can be called as a branch of it, because we are generating a tree, right? So there will be there could be some branches also, and let's say this doesn't have any branch. Okay, let me just delete it. So this will be called as terminal node, because that's where your branches are terminating. No more further decision. This is the end result. Okay, and let's say you have some further result here. Now this will be called your terminal node. That's where your tree is getting, or branch is getting terminated. Correct? It's terminal node. Then we have leaf, we have decision node, as well as root node. Now we have something called pure node. What is this pure node basically? Pure node is nothing but after that, let's say this, since we don't have any further category, right? So this, whatever result you are getting, this must be belonging to, to become any node as a pure node, they must belong to one category only. When I say one category, right? So let's say here we talked about quitting and not quitting, right? So there are two categories, quit and no quit. So let's say after making a decision tree, we finally got this is basically this particular data, or this particular set of person belongs to only quitting. Okay, here they are belonging to no quit only. Okay, so when you have only one category left in the node, that is called pure node. Okay, this might be asked in the interview also. What do you understand by pure node and impure node? Okay, so this is also pure node, because only it has one category. Okay, there's no impurity. Basically, you are having two or multiple categories in one node, or multiple data are there which is belonging to different category. That is called impure node. Okay, so impure node can be taken this in the form of whatever decision nodes are there, right? That is basically impure node. Why it is impure node? Because they are having two categories, right? Yes and no. Correct. So that's why this is called impure node. They are belonging to two different categories, and because of that only you are getting, again, your branches are getting bifurcated, right? And once branches are terminated, they must be belonging to one particular category, and that is what is pure node. Okay, so that's about this. And now we have another terminology called entropy. What is this entropy basically? This in the data represents basically, let me just write, represents how random is your data, or randomness in the data, in a data set. I'll mention in a data set. Okay, so let's say you have only one category that has only yes, or maybe only quit, based on my previous example, right? Only quit data. Okay, so if only one category is there, means there is no randomness. It is pure node or pure data, so there is no entropy. In this case, entropy will be 0, because it is pure. Correct. Now we have something called mix of categories. Okay, yes is also there, no is also there. You can say, let's say, positive and negative. Okay, so when you have mix of both, we have some entropy. Entropy is present, or we can say randomness in the data is also present. Okay, that's what is your entropy. Okay, so while building the decision tree, we have two kind of category. One is entropy, and another one is called Gini impurity. So we'll see about this terminology, what is this and where exactly we use it. Okay, so we'll see mathematical intuition also behind this, how to calculate entropy. If you are going to build a decision model or decision tree model, how we can use entropy, how we can use Gini model or Gini impurity. Okay, so we'll see that. So remember that we have two kind of thing, entropy or Gini. So based on two different what do you say parameter, you can create the model. Okay, now let's talk about what is entropy. As I mentioned, it is showing as randomness in your data. Okay, so let's see how to calculate the randomness. I'm going to load one picture here which is going to explain about, you see where is decision tree. Yeah. Okay, there's one small data set where we are talking about some parameter. Okay, and based on the parameter we are going to decide whether to play cricket or not. Okay, whether to play that game or not. Okay, so what are those parameters? These are nothing but the features or variable, I would say. Outlook, temperature, and humidity, wind. If outlook is sunny and temperature is hot and humidity is high and wind is weak, then we are not going to play the cricket. Okay, now similarly we have sunny, hot, high, strong. Again we are not going to play cricket. Okay, or not going to play any game. What about this? If it is overcast, hot, temperature is hot and humidity is high and wind is weak, we are going to play the cricket. Okay, so what is this basically? This is nothing but your target. This target says whether to play cricket or not. Okay, and this particular target is depending on all these variables. Sorry, these particular features: wind, outlook, temperature, and humidity. Okay, now as if you remember, I talked about the tree model, right? So we have something called root node. This is root node. Now, once you get the data set right, you may get question like which particular feature to be taken as a root node. Okay, so to decide root node, we have something called information gain. Information gain. This information gain is telling basically which particular feature is providing more information. Okay, so once you calculate information gain, there's a mathematical formula. I'm going to talk about this also. Whichever feature is providing more information gain, that will be taken as your root node. And after that, remaining feature, again we are going to run the information gain for that node. Whichever is leading, we will take that as a further node, further like child node of that root node. Okay, so it will be like this. Let's say information gain is very high. Okay, this will be yours selected as a root. Now after this we have so many other feature, right? So let's say here I'm just taking here one node as outlook as root node. Okay, root node. So under outlook we have what? We have sunny, then we have overcast, then we have rain. Correct. Now which one to under this, which particular root, which particular child node is going to come, whether it is going to be temperature, humidity, or wind. Okay, so again we are going to calculate information gain for temperature, then humidity, then wind. Let's say humidity is going to wind. Okay, so humidity is going to come under sunny. Okay, then again under sunny, this is a child node and it is having high or normal. Okay, these two category will be there. Again, if we have further category, we are going to run information gain again with the remaining features. That's how this recursive method will keep going on until you get the final data. Okay, so let's talk about the formula, what we are going to use. So I'm going to load this picture again. Entry. Okay, so first of all, we should know what is entropy. What is the formula for entropy? So entropy represents as H of S. Okay, set of data, and where entropy can be represented as minus. Remember this, and this is minus I of I starting from 1 to n or 0 to n, whatever, or 0 to k. Let's say k is nothing but your number of classes in that field. Okay, and probability of getting k multiply by log of 2 base of 2 probability of k. Okay, so this is your entropy. So now why what is my class here, the target class? This is play cricket. Okay, so how to calculate basically? So first of all, how many total number of elements are there? So this is nothing but total 14. Okay, out of 14, how many yes is there? So what is the probability of getting yes? What is the probability of getting no? You can say this as a positive and this is also negative. Okay, you can represent like this. So I 1 to k, probability of getting positive, log of 2, probability of getting negative. Okay, so total number of yes is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 out of 14. Correct. So this is the probability of getting yes is now 9 by 14. Now probability of getting no is 1, 2, 3, 4, and 5. 5 by 14. Put in the formula. So this will be your, let's say positive is how much? 9 by 14, log of 2, 9 by 14. Okay, then minus 5 by 14, log of 2, base is 2. Okay, 5 by 14. If you put, if you do complete calculation, we are going to get 0.94. Okay, this is your entropy of given data for the categorical value. Okay, now this entropy is going to be used further to calculate the information gain. And what is information gain is telling? Information gain, let me write, is used to decide which feature to use for root node. This is very, informative thing. You should know this, how to calculate information gain, because this is what is going to tell you, like, this is the feature I'm going to use as a root node. Okay, so now let's see how to calculate. So we have information gain as entropy, or h of s minus I1 to k. We have probability of getting s and multiply by h of x. X is nothing but what is the subcategory. Okay, so this entropy we have already calculated, that is 0.94 for categorical value. Okay, now for this one we are going to calculate for each feature. So this s is nothing but, let's say I'm going to calculate first for outlook. Okay, after outlook we are going to see how many subcategories are there. We have sunny, then we have overcast, and we have rain. Correct. For each we are going to calculate. And for sunny, how many yes and no are there? For overcast, how many yes, no are there? And for rain, how many yes, no's are there? Okay, and put everything in the formula and calculate the information gain. Okay, so this we are going to do for all outlook. Okay, as a temperature, humidity, wind, and finally we are going to get which particular feature is giving more information gain. And that is the one which is going to lead. Okay, and the leading node will be taken as a leading feature, will be decided to take this as a root node. Okay, so let's go ahead and run once again. It's very important. Okay, so this particular thing we need to understand properly. So for this particular category, what we got is for entropy for the target node, what we got is as 0.94. Okay, now let's calculate information gain for outlook. Okay, so for outlook, let me calculate only for one so that you guys can understand. We have sunny, then we have overcast, then we have rain. Okay, for sunny, how many yes or no there? So for sunny, let me use the red color. So for sunny, we have total yes, total no, and total. Okay, so for sunny, how many yes are there? We have, first let's calculate no. 1, then 2, then we have 3, then we have, yeah, total 3 no. How many yes? Let me use blue color. So yes will be 1, then we have 2, right? Just put 2. So total how many? 5. Similarly, you calculate for overcast. For overcast, how many yes are there? So we have 1 yes, then 2 yes, then 3 yes. So looks like 4 yes, correct? So 4 yes and 0 no, correct? And how many no's are there? Let me just see if any no is there. No is 0 only. So this will be total 4. Okay. Now we have rain. So rain is how many? So rain, yes, yes, 2. Then we have 3. Then yeah, 3 rain, 3 yes, and total no, 1. Then 2, right? So total 5. So how many total we got? 14, correct? And total yes. So for Sunny, what I can give information gain for outlook of Sunny. Okay, so what is the formula we had used, right? H of S minus I equal to 1 to n probability of that feature multiply by H of that particular category X. Okay, so what is my probability? So for getting yes, total probability is what? Where is that? 5 total 14, and for Sunny we have total yes as I think I made a mistake here while calculating. So total number of features is 5. Okay, for Sunny 5 by 14 over 14. So probability of getting Sunny with yes. So Sunny getting is 5, right? Sunny getting 5 by 14 multiply by total getting yes. So yes, that is nothing but 2 by total getting yes out of how many? 2 and okay, 2 by 5. Yeah. So 2, that is nothing but 2 by 5, that is yes, multiply by log of 2 by 5 minus 3 by 5 log of 2, 3 by 5. You calculate this, okay? And similarly for overcast also we'll calculate. So what is the value? We will get this, okay? Now for overcast we have 4 by 14 multiply by total 4, 4 by 4 log 4 by 4 and minus, this will be minus. Anyway, this is going to be 0, okay? Because we have 0, right? 0 multiplication. So that is no 0. I think this is going to be 0. Now next is for rain. So this is for Sunny. This is for overcast. This is for rain. Okay. So for rain, we are going to have 5 by 14. So out of 5, we have 3 s. So 3 by 5 log of 2, 3 by 5, that is minus, and minus then 2 by 5 log of 2, 2 by 5. You calculate all the values, and we are going to get overcast. Where is that? This for outlook, right? So finally we will get the, so you just add it because in the formula what we have added, this is the summation, right? Okay, so after doing this overcast, we are going to get outlook as, just for example, we are going to get 0.9. Similarly for temperature we'll get some value, let's say 0.08. For humidity we are going to get something 0.0. This just for example, okay? So outlook is going to be on top, so information is going to be very high for outlook. That's why we are going to use outlook as a root node. Okay, so after making the root node as outlook, what is going to happen? So this will be your outlook. Now this root node is selected, and after it what we have? Sunny, then we have rain. These are the three decision, right? Then we have overcast. Now, after this, which child node is going to come out of remaining features? That is temperature, humidity, wind. So the way we calculated for outlook, we are going to do same procedure for temperature, similarly for humidity and wind. Okay, and this humidity is going to lead. So this humidity will come here. Humidity. Okay, and this will be again having some child node here high. Then we have normal. You keep doing that, then finally your tree will be ready. Okay, and each node you will have the value like where you are going to have yes, no, based on the feature value. Okay, so this is the mathematical or the procedure behind creating the decision tree, especially for the node, root node, then child node. Okay, so as I mentioned earlier, right, we have two way to create the decision tree model. One is like entropy way, entropy plus information gain, and another one is Gini. So Gini is nothing but the way is in the information gain we are using log, right? But in the Gini gain it will be just 1 minus summation of I equal to 1 to k probability of what to say I to the square. Okay, so you do the summation of all and without log. Okay, and finally you are going to get the value. So let me show one graph like how it is different from entropy. Let me just use duplicate tab. So what basically happens when you just plot the, let's say here you are plotting, this will be your y-axis will be your entropy, and this will be your, let's say, probability. Okay, so let's check this one. So you saw the formula, right? Under entropy we had 1 minus sorry, I equal to 1 to k probability of getting I log of 2 probability of getting I. Okay, so basically all the probability you are going to add. Now let's say you have yes, in total no. Okay, so total 5 numbers are there, and out of 3 yes and 2 no are there. Okay, assume that sorry, let's say total 6 are there, so 3 yes and 3 no. What will happen? Minus probability of getting yes and log of 2 probability of getting yes. What will happen? So 3 by 6 log 2, 3 by 6. Similarly, you have 3 by 6 log of 2, 3 by 6. Okay, some value will be there. So in this case, what will, when equal number of categories are there, right, your entropy is going to be very high. Okay, so let's say your entropy is very high. Let's say this is 1 and this is your value. Okay, and when let's say you have total number of yes equal to 6 and no equal to 0, so what will happen if you put this in the formula? One of them will make 0, so everything will become 0. Okay, similarly you have total number of yes equal to 0 but total number of no equal to 6. So again, one of the categories are going to be 0, so whole probability is going to be set as 0, right? If you just plot those value, right, let's say you are plotting just by manipulating all the value, right? This is going to be your entropy. Okay, but what about the Gini index or Gini impurity? It is 1 minus summation of I equal to 1 to k and probability of I. Okay, so 1 minus, let's say equal number of probabilities are there, then what will happen? This will be 1, exactly 1, correct? Or 0.5 plus 0.5. So 1 minus 1 equal to 0. You are going to get 0, correct? So 0.5, just a minute. If you have equal number, then it will be exactly 1. Yeah, it will become 0. Okay, so this will be going to come here, and this is going to be, this will be a 1 minus 0.5. This will be a 0.5. Yeah, so the maximum Gini index, what Gini impurity you can get as minus, sorry, not minus, actually 0.5. Okay, this is going to be here, and all the let's say you have one category only. Let's say you have pure node, right, where Gini index will be differently. For one category it will be 0, another category it will be high, correct? So it is going to be very much minimal, and when the moment both the classes are going to be equal, then it is going to be high, and one is going high, another one is going down, then you are going to get 0. Okay, so Gini index scale will be maximum 0.5, and for entropy you are going to get maximum 1. This is the main difference between Gini and entropy. Okay, so that's all the mathematical notation behind creating the decision tree model. Now let me go ahead and show the example. Okay, so what we'll do, I have written everything here, all the formula, and Gini index is also written here. Okay, this is a square. I forgot to mention the square here. Okay, this is nothing but the square here. Okay, now let's go ahead and run the example. So as usual, I'm going to import all the library. Under tree, we have decision tree classifier. Then these are the other library which will help you to draw the tree diagram also. Okay, so export graph viz, export text, and plot tree. So plot tree is the one which is recently added in scikit release, but this was not there earlier. So we had to use export graph viz to plot the tree. Okay, so right now, okay, I just showed you guys, but I'm going to use plot tree only. Okay, then we are going to use train split. Anyway, I'm not going to use accuracy score and confusion matrix for showing the prediction. Okay, so let's go ahead and run it. I'm going to use iris dataset, and this is xy xtrain decision tree classifier. If you see here, right, by default it is using Gini index. So why it is using Gini? Because I have mentioned the benefit of having Gini also, because it is computationally very fast and more accurate than entropy, because entropy will calculate the log. It is going to take a lot of time if your data set is very big. But in case of Gini, it is not taking log. It is just 1 minus summation of a probability of that particular category to the square. Okay. So that is the reason by default it is Gini, but you guys can just write entropy also if you want. So let's go ahead with the Gini and run it, and let's see the accuracy score. We are going to get 93%. Okay, and if I run confusion matrix, then let's say y pred. What happened? Oh, y test. Okay, so you see here 14 7 1 1 7. So there are some misclassification also. You see here one, this one. Some classifications are wrongly, some values are wrongly classified. That's why you're seeing this. Okay, let's go ahead and visualize it. SNS dot heat map. Then I'm going to pass the whole thing here. Okay, annotate true. Okay, so 0, 1, 2 is nothing but your Setosa, Versicular, and Virginica. Those classes are there. If you want to see the which class we are going to refer here, so T, we have something called classes. Setosa. So this is your 0, 1, 2. It will be always in the order 0, 1, and 2. Okay. If you see here, 0 is nothing but your Setosa. So Setosa all fine, and here's 1 is nothing but your Versicular, right? So Versicular, out of 8, we are here rightly classifying 7, but 1 is getting classified as Virginica. You see here, correct? So this is what that 7% accuracy, right? That is going wrong. Now get text-based decision tree details. So how we can load the whole tree? We have something called DT export text and give the classifier, that is my decision tree. Okay. So if you are printing it, you can get the text-based. Yeah, this is the way. So the one which we saw here, right? All the decision tree, this is nothing but it is also known as dot notation or text base. So based on dot, it has taken the feature 3, then it has classified, and feature 3, which is greater than dot, pointed how many features are there, what child categories or child nodes are there, all the details. But here it is not very readable, very not user friendly. We are going to plot them. Okay. So how to plot? There are two ways. So one is like plotting using graph viz. So I can go ahead and import these library. If you don't have, please go ahead and install it using pip install. Okay. And if I plot like this, where is image? Sorry. See here, very nicely it is going to put. Okay. So petal length, it has taken the petal length as a root node. Why? Because Gini index, sorry, information gain for the petal length would have been very high compared to sepal length, sepal width, petal width. Correct? Sorry, petal length. That's why. So you got this 0.8, and Gini is almost close to 0.665. Okay. So total sample 120, and that is going to divide in true or false. So petal width, which is less than 2, less than 8, is it true? Yes. If it is true, then how many classes are there and how many data set is going to come under that? If you see here, right, this is what I was talking. If after this node you are not seeing anything, means it is a pure node. Why pure node? Because you see it belongs to only one particular class, that is setosa. Okay, and under this particular thing you see this is not pure node, this is called impure node, because here we still see two categories, 42 and 42, correct? So one belongs to versicolor and one belongs to virginica. Again, putting the condition like that, you just keep dividing in the recursive way, and finally you will reach to every node which is having only one class. You see the last one, Gini is 0, and you see only 3 values are there which belongs to virginica, and in this Gini we have only one class which belongs to versicolor. Similarly others. Okay, there is another way to plot it. So this is older way. Okay, you guys can just go ahead using plot tree. What it needs, the classifier, that is dt, and if you just run by default, let me just store all the outputs, plt dot, so okay, and here we have a couple of categories to make it little bigger. Maybe what I'll do, I'll just make plt dot figure fix size, let's say 10 by 8. This may look better, yeah, better than previous one. And we have something called round equal to true to make square boxes more beautiful. Then we have something called filled equal to true to make it more colorful. Okay, let me increase 14, much better. Okay, now after that we get, you see here by default if you don't put the classes, right, it's going to return me x comma 3. So because x is nothing but total data set, right, from that we are taking third one. So what is this value basically? So it makes sense to use the feature name. So what is the variable basically? Feature names, right? So feature names equal to, I'll give df dot, let's say keys, -1, all but -1. Let's see if this works. Yeah, because if you see, right, my data set is having what? Iris I have loaded, right? If you load here df dot red 4, these are the feature name, right? So that is what I did. And -1 why I gave, because species is nothing but the target value. So I have to use only these particular variable. Okay, that's what I gave here. And what else? We have feature name and number of classes. If you see here, classes it is not going to give, right? It is not mentioned. So what we can do, we have something called class names. That is nothing but dt, from dt we can take the classes. Now it is going to put the classes. Also class belongs to versicolor, then this, and here we have something called font size. Let's make it 10. So to organize it better. Okay, so that's how you generate a decision tree. You do the plotting. Plotting will make more clarity how the decision is being made and which particular data belongs to which class. Okay, so that's all about decision tree, and couple of advantages I have mentioned it. So definitely decision trees are super interpretable, because it is like, you know, going with if else condition and making the judgment and creating the results, right? Require little data pre-processing, suitable for low latency application. Okay, what are the disadvantages? More likely to overfit noisy data. The probability of overfitting the on noise increases as a tree gets deeper. Right now this data set is very small, but the moment you have very large data set, it is going to add a lot of noise. Okay, so a lot of branches will be there, and that will add a lot of noise in the data. And solution is pruning. So pruning is nothing but, so pruning is basically removing the branches which is not going to add much value, like we do, right? Feature engineering, we don't take the features which is not at all going to add value. Similarly here we may remove some of the node or branches which is not adding much value. Okay, another way to avoid overfitting is to use bagging techniques like random forest, which I'll make the next video. Okay guys, so that's all about decision tree. I hope you understood the decision tree concept, and please run the notebook in parallel and understand, play with different data set. I took the iris, you take another data set, and understand how it is working. Okay guys, and this particular thing is also known as cart, basically classification and regression tree. Okay, so we have taken the categorical value, so it is basically for classification. When you have the value which is continuous, then it will become the regression. That's why it is also known as cart model. Okay, so please remember that. Okay guys, that's all for today. See you in the next video. Thank you. Bye bye.